This call is now being recorded.
Drawing the electron configuration for larger atoms. By larger atoms in Gen Chem, refer to atoms larger than calcium, so larger than 20 protons in the nucleus. When drawing electron configurations for larger atoms, there are a couple more rules to keep in mind to get the correct or lowest energy electron configuration here. Let's quickly kind of go over the rules and draw the electron configuration for up to calcium. And then when we get to this first row of the 3D set, we'll try to pepper in a couple of those rules or a couple of those circumstances. So very quickly, let's kind of review how to fill in our periodic table with electrons while drawing out an orbital energy level diagram of all those electrons there. The periodic table with its principal quantum numbers of 1, 2, 3, 4, its second quantum numbers of L equals 0, L equals 1, L equals 2, and we can plug in and fill in our electrons. Periodic table is really great for filling in electrons. Let's move this box over here though, because that is a box for an S electron. So there's our first in there. Those are the 1s2 electrons. Spin up. One is electrons that spin up, the other electrons that spin down. Now fill in the next 2 electrons. They're going to be a 2s2, a spin up, spin down. Now this table I am filling left to right, top to bottom, just like you read in a book. This picture I'm drawing here, I am filling up. And it is as I am filling electrons that get farther away from the nucleus. The 1s electrons are the closest, the 2s a little further away. So I have this slice showing it here with the electrons. Filling in left to right. 6 electrons going here in the 2p6. So here's my 2 level. These p electrons, the 2p6, I need 3 orbitals. Mother Nature has 3 orbitals to fill in those 6 electrons there. 3s2. Three p6. And again, these electrons are getting farther away from the nucleus as they are higher in energy. 4s2. And that would be the neutral electron configuration for calcium. All of this stuff here, also that mouth jumble right there. Now, when you start filling in more electrons than that, there is a level that is inserted in there, the 3d orbital set in there, that can hold up to 10 electrons and has 5 orbitals in there. So 3d, 1, 2, 3, 4, 5. Couple of things now, when filling in electrons for elements in this block right here, let's do iron, for instance. So I have my electrons filled up to the same box that iron would occupy in here, and 6 electrons are what goes in here. 1, 2, 3, 4, 5, 6. So these electrons are spread until they fill up in there. And that's really a great answer for iron, for the electron configuration for iron, or for any real larger atom. Just continue with the pattern. Just continue with the pattern. That's a good answer for Gen Chem. It's not the best answer and it's not a great answer. Let's consider some of those little circumstances where you can polish up your answer a little better with some more rules that help us predict electron behavior here. So for example, let's do the chromium neutral electron configuration. I'm going to erase a couple electrons here. And also I'm going to erase this 3D set here. We're going to end up redrawing this here. So following this pattern, whoops, let me fill this up here, chromium. So again, I have my electrons filled into the same box that chromium occupies on the periodic table here. And then just following along with the pattern, 4s2, 3d4, 1, 2, 3, 4. Now, electrons are always striving to spread themselves out as much as possible within similar energy levels here. Now, these orbital energies or orbital distances from the nucleus is what I'm trying to represent in this picture here. The 3D and the 4s set are very similar in energy. A habit of electrons is that they like to have half-filled orbitals before wanting to pair up. So consider that this 4s2 orbital is full, and there is a vacant 3d orbital here. What will happen is one of these electrons will move over to that orbital, and now we have a situation where these 6 orbitals are half filled. So our electron configuration for chromium would be all this stuff, 1s2, 2s2, 2p6, 4s1, 3d4, because of electrons' habit to half fill an orbital before wanting to double up here. And these are similar in energy. This half fill, this advancing of an orbital to half fill doesn't happen until we get to the 4s 3d or 5s 4d shells here.